Hello everyone, in this presentation we are going to understand how to measure the thread length calculation for a vertical wall cleaning robot. So the plane that what we have chosen here is 3 feet cross 2 feet, that is 90 centimeter cross 60 centimeter plane which we are about to clean. So this 90 centimeter cross 60 centimeter plane is segmented into 15 centimeter cross 15 centimeter square grid. So if we segment this 90 centimeter cross 60 centimeter or 3 feet by 2 feet plane into 15 centimeter grid, we will be getting 4 columns and 6 rows as we see here. So if there are 4 columns and 6 rows, there are 24 segments. We will get 24 segments in this plane. So the objective is to clean all the 24 segments. For that we are using the hanging mechanism, and we are going to make the 15 cross 15 square box as a carrier, and this carrier should placed in all the 24 places. That is the whole objective. So this is the cleaning robot in the vertical wall. So the 15 cross 15 robot, say for example the robot with 15 cross 15 model, as you see here, the robot with 15 cross 15. So there is a hanging mechanism with 15 cross 15. So here there is a motor, and here there will be another motor. One thread will be connecting to this particular motor, another thread will be connecting to this particular motor. Say for example, I want to clean this particular 16th segment. In this 24 segment, there is a left motor in the top left corner, and there is a right motor in the top right corner. By controlling these two motors, the corresponding thread will keep this particular box or the carrier or the cleaning mechanism in the right position, 16th position. So the presentation objective is to make us to understand how to measure the thread length calculation for the left motor and thread length calculation for the right motor to keep this box in the 16th position. So for that, when we come down, so this is the thread length calculation mechanism, and this is what the 16th block thread. So because as we discussed already, every block is 15 centimeter. Every block is 15 centimeter, as we know, because it is a square box. Both the row and column both are 15 centimeter. So if so, to find out this thread length, this has become the right angle triangle. If you look at here, it looks as a right angle triangle. So something like this, as we see here. So this is the right angle triangle as we see here. So this right angle triangle height is 30 centimeter. Why? Because so this is 15 centimeter and this is 15 centimeter. So 30 centimeter height, and the length is only 15 centimeter because it is the only one grid. So 15 centimeter. So if you want to find out the length of the slope, that is the length of the thread from the left motor, means we can use the very simple formula like square root of length square plus height square. So the length is 15 centimeter, so 15 square, and the height is 30 centimeter, so 30 square. So square root of 15 square plus 13 square is nothing but square root of 1125, which is 33.54 centimeter. So the left motor thread length should be 33.54 centimeter in such a way that we can position this particular box in the 16th position. So the left motor thread length should be 33.54 centimeter. This is 33.54 centimeter from this point. So we can position this particular box in the 16th position. So similarly, we can calculate the right motor thread length by the same principle. So here this is 15 centimeter, here this is 15 centimeter, here this is 15 centimeter, here this is 15 centimeter. So this is again, it has become the right angle triangle. So that is what shown here. So 30 centimeter as 30 centimeter, and this is the thread length for the right motor. So here we have a right motor, here we have a box, and the thread length for this right motor can be calculated by square root of L square plus H square. So length is also 30, height is also 30. So 30 square plus 30 square, 900 plus 900 square root, which is nothing but 1800. And if you find out the square root, it is 42.43 centimeter. So right motor thread length is 42.43 centimeter. So from this position the right motor length should be 42.43. So this is 42.43 centimeter and this is 33.54 centimeter. If you position these two threads in this particular length, we can able to keep this object in the 16th position. So that is what we have experimented, that is what we have computed, and that is what tested in the vertical plane with the grid. So we have to connect the motor and then we have to experiment it in the real hardware. That we are going to discuss in the next video. Thank you very much.